Yes, students, good morning. Jai Swaminarayan. In the last lecture, section F of exercise 2, we did up to sum number 3. Today, students, we are going to start from sum number 4. Only one sum is pending. First of all, students will complete sum number 4. The data regarding height in centimeter of 30 students of a school are as under. Prepare an inclusive continuous frequency distribution of 6 classes. Okay, number of classes are given, students. So first step is to check the lowest and students the highest observations. The first step is to check. You can say the highest is 168 and lowest is 141. Okay, students, section F, sum number 4, we are writing here XH is equal to 168 centimeter, XL is 141 centimeter, so range is equal to XH minus XL, 168 minus 141. So the range is 27 centimeters. Now, number of classes given are 6. Number of classes K is equal to 6. So class length is equal to range divided by K. 27 divided by 6. 6 4s are 24, so approximately 4.5. And if this is 4.5, number of classes we will take, class length we will take 5. Now C into K, C is 5, K is 6, which is 30, that is greater than or equal to 27. So C into K must be greater than or equal to R. This must be, students, always you can say satisfied. Now let us go for the frequency distribution. So I start with inclusive frequency distribution of the data is regarding students' height of students of a school. So inclusive frequency distribution of height of students of a school. Now, the first column is classes, then tally marks, and then F5. This is T, tally marks. Now, the lowest value is 141 students. So I can start classes from 142. Class length is how much? 5. So the first class would be 140 to 144, not 145, because this is not exclusive, it is inclusive. There should be a gap of 1. Second class will be from 145 to 149, 150 to 154, 155 to 159, 160 to 164, and last class will be, students, 165 to 169. And tally marks, if you can do, the frequencies are 2884, 2884, and last two frequencies are 6 and 2. 6 and 2. So this total is nothing but 30. So this is our table of frequency distribution. Here we can write total. So this part, tally marks I am not showing. Now prepare less than type and more than type cumulative frequency distribution. Now students, pay attention. For inclusive, we have to take boundary points for, you can say, cumulative frequency distribution. For exclusive, class limits and boundary points are same. But for inclusive, class limits and students boundary points are not same. So we will give the heading less than type cumulative frequency distribution. Less than type cumulative frequency distribution of heights of students. Now, in less than type, the first column is height less than. In less than type, we use upper boundary points. So, less than upper boundary points, and then corresponding cumulative frequency distribution. Now, the first upper boundary point here, students, I am showing, if you want, I am showing the boundary points. Besides these classes, you first note down this much and erase it, so that it will be easy for you students to write. I am showing the boundary points, students, and the boundary points are 139.5 to 144.5, 144.5 to 149.5, 149.5 to 154.5, 154.5 to 159.5, 159.5 to 164.5, 164.5 to 169.5. Now students, in less than type we take upper boundary points, but we always start with the value before. So 139.5 to 144.5, 149.5, 154.5, 159.5, 164.5 and 169.5. Now in less than type we start with 0. There are no values for less than 139.5. Now go on adding 0 plus 2, 2, 2 plus 8, 10, 10 plus 8, 18, 18 plus 4, 22, plus 6, 28 plus 2, 30. We end at maximum and we start with 0. Now, more than type. More than type. Cumulative frequency distribution of heights of students. Again, same two columns. Here we write more than or equal to upper boundary points. More than or equal to, sorry, lower boundary points. Sorry, students, my mistake. I told upper boundary points. It should be lower boundary points. Sorry, students, my mistake. I told upper boundary points. But in short, we have to take all boundary points. So 139.5, 144.5, 149.5, 154.5, 159.5, 164.5 and 169.5. In less than type we take upper boundary points, in more than type we take lower boundary points. Here we start with maximum. So 30, go on subtracting first frequency 2, 28. 28 minus 8, so 20. 20 minus 8, so 12. 12 minus 4, so 8. 8 minus 6, so 2. And the last frequency is 0. So here we start with maximum and we end at 0. Now still the sum is not over, students. This is a very lengthy sum. First part was frequency distribution, second part was less than type, third part is more than type, and now we have to answer the questions. If participation in the NCC activities requires a minimum height of 160 centimeter, then how many students are eligible for participation? Minimum height is 160. So number of observations which are 160 or more are 6 plus 2. How many? 8. So directly writing answer 1. 6 plus 2, 8 are eligible for participation. Second, find the number of students having height from 153 centimeter to 163 centimeter. 153 to 163 we have to directly check the observation, and the answer is 12. So answer to height from 153 centimeter to 163 centimeter we have to count and write, and the number of students for that are how many? Then 12. Sorry, the last question. The maximum height of 1/3 of the students having minimum height. Now pay attention. 1/3 of the total students, 1/3 of the total 30 is 10. So that will be this three. And this first two classes only will bear minimum height. In these 10 students who are having minimum height, what is the maximum height? 149 centimeters. So the answer 3 is students 149 centimeters. This is also a very tricky question. 1/3 of the students are having minimum height. 1/3 of 30 is 10. So this first two classes will bear minimum height, and the limits is from 140 to 149. Of these 10 students who are having minimum height, what is the maximum height within this range? Then the answer is students 149 centimeter. So students, this completes our long section F. Students, I think this completes our long section, which is section F. Now students, sorry, I think